Okay, hello everyone. Today we're going to be exploring the Core Attractor Point Dynamo sample file. So you'll be able to find this file under the Help, Samples, Core, and Core Attractor Point. Okay, so as usual, I'm going to be taking a screenshot of this, and I'll be able to open a Sublime text window, and I'll just type in the pseudocode of what is there to do. So let's go ahead and do that. Take a screenshot. There we go. So what is happening here? It seems that we have a bunch of cylinders being generated around a pattern of grids around this sort of square right here. And these cylinders, the height of the cylinders and the radius of the cylinders seem to be modulated by the distance around the center of these cylinders, and that's called an attractor point. Okay, so what do we got to do? We got to generate a bunch of cylinders. So let's go ahead and type some stuff here. So we got to make cylinders and make these cylinders react to the distance to a point. Okay, so let's break it down a little bit more. Okay, so to make these cylinders, how do we make cylinders? It looks like we have a bunch of circles being laid down. Okay, so we have to create cylinders onto which circles, onto which these cylinders are based on. So maybe make circles. What else? We have to create that attractor point right here. So make an attractor point. And also we have to, in order to make these cylinders, we have to, it's not enough to just create one cylinder, obviously. We have to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a 10 by 10, 100 cylinders along an even square grid. Okay, so, and also make cylinders, we'll make 100 cylinders in a grid. So we'll probably have to break down a few of these into smaller bits in order to be achievable, because there's no node inside of Dynamo that says, hey, create those cylinders magically in a grid. So first of all, we have to create a grid. Make a grid of points. And from those points, we have to make cylinders. So let's delete that actually and make and put that here. Make an attractor point. Okay, so that's pretty much the kind of breakdown if I had to write it in like a few simple phrases. So the first step, make a grid of points. How do we do that? Okay, so I'll teach you how to do this guy. Let's go back to Dynamo and start over. Okay, so we have a clean file. So as we explored earlier in the previous video, we found out how to make points and how to make lists. So let's start with the same node we used earlier, the point.ByCoordinate. Point.ByCoordinate, that's the first one. And we also learned how to make lists. So we used the sequence node. So this creates a sequence of numbers and stop amount. Okay, and we also need a node to create a cylinder, right? Because if we look at our screenshots, there's a bunch of cylinders being generated. So let's type in cylinders. Okay, we have a few options right here. So this one's creating a cylinder based on the start point and end points. We don't want that. And the radius coordinate system. height, and yeah, that seems more appropriate. Okay, so by default, it created a cylinder in the origin. And okay, so if we feed that point into the cylinder, it says, oh, something's going on. It's not a coordinate system. Okay, so let's try, say this double. Let's try another way. Let's use circles instead. So radius normal. Okay. Now we need a grid of points in order to generate that grid. So how do we generate a grid of points? I'll show you how. So where's my point by coordinate? Ah, it's gone. Anyway, let's put another one in. And let's say we want to generate 10 circles along the x-axis in red right here. So we put it here. Oh, so it's got a default bunch of values set up right here. So let's see what this does. 0, 1, 2, 3, 4, 5. Okay, it's good, but it's not great. We still want our start to be based around 0. It's the default value. We don't have to change anything. The max value, we might want that to be a little bit different. So let's put a number slider right here. No, let's put an integer slider. We don't want a number. Integer. Okay. Let's put the maximum to around 30 and the minimum to 2. And feed that into the step. So as you can see, I'll be able to go and change the amount of points, not the distance of these points, the step, as illustrated here. I can also choose to have a certain amount. In this case, we want to stick to the number inside of our screenshot, which was 10 by 10. So we just leave that in. I mean, I'm just going to put 10 anyway so that it's more clear for you guys. And the start was 0. Okay. Now we got a bunch of points along the x-axis. We also want that bunch of points across the y-axis and everything in between in that xy plane. So what happens if I put sequence into y? Okay, we get a diagonal line, same, only a bunch of 10 points along the xy diagonal. So the trick here, in order to make the grid of points go in a square to get 100 points, is to go and use lacing. So you right-click onto the point by coordinate nodes. Let me just expand that so you guys can see what's going on. At the moment, we have 10 points. And to get 100 points, to get 10 by 10, you go right-click, lacing, and you go into cross product. So it'll multiply both inputs and get a cross product. And if I click on that, you'll see, boom, 10 points. And they're arranged in lists. So we have 10 lists, and you can collapse or expand these. And as you just saw, when you click on one, it highlights and labels all of these. So you have to bear in mind that these lists, all the lists inside of Dynamo are what's called, they're based on a zero, there are zero-based indexes. So the first one is at index 0, and the list inside of that list is also, the first one is also a 0. So just bear that in mind. It's useful for the future reference. So we have 10 lists, each constituting of 10 points. And as you can see, when I click on one, they're all based in rows or columns, whichever way you want to conceive it. And it tells you which one they are. Okay. And you can always go in there and just say, hey, I don't want these each circle to be, point rather, to be separated by 6 units, but by 5. So if I put 5 in here, we get a grid of 100 points with going from 0 to, is it 50? There we go. Anyway, or 45 in that instance, rather. Anyway, so now we put our lists of points right here into the input of center point. And we get 100 circles, just like that. Okay, so we're getting there. We're getting there. Now we need to turn these circles into. We need to extrude them and make cylinders. So if we extrude circles, it's going to give us kind of shells, and that's not what we want. We want to turn these guys, these circles, into surfaces. So there's a node for that, and it's called surface by patch. So if I go type patch, I rarely need to type the whole thing. So it says right here, that's the second one. Create a surface by filling the interior of a closed boundary defined by input curve. So it takes closed curves as input, which is perfect, because circles are closed curves, and feed all of these circles into that patch. And all of a sudden, I have my circles turned into surfaces. And now we need to extrude those surfaces in the Z direction. Right. We're getting there. We're getting there. So if I go geometry, surfaces, and I want to thicken. Okay. You don't actually extrude surfaces in Dynamo, you thicken them. You can extrude curves, but surfaces, you thicken them. So let's choose this one for practically the same. You can choose which direction, which normal direction you want to thicken from. So now we have these surfaces, we fit them into this. And as you can see, it already started thickening them in both directions. That's because by default, I've got the both sides set to true. If I want only one direction, I have to define this value as a false. So I can just go in here, create a closed block by double clicking and typing false. Oh, not typing, false. There we go. Or I can choose to use the Boolean node. So I right click and type Boolean. Here we go, the first one is here. And I like to use this one better because actually I can just go in here and just type and switch between the two whenever I want. So instead of typing true and false, but again, or I can just go true like that, and then true or false. Anyway, I still like to use the node. It's just a little bit cleaner. Anyway, we want a false and set it to there, and we want let's just put a random value like 10 at the moment, just so that we can see a clearly that it's being extruded. All right, so now we're missing a couple of things. So let's go back to our thing here. Let me just shut that off. There we go. So we're missing the attractor point, and we're missing a way to modulate the height and the radius of all these cylinders. Right. Okay, so let's start by creating the random point of the arbitrary attractor point. So right click, point, and just so that it's clear, you can see that my point is right here, and I'm just gonna pop it right in between. Yeah, right here. That's good enough. Right. Now, how do we modulate the radius? Let's start with a radius first. So the radius, we can see here that we have a radius input. So if I type 4, we get much a bit too big, but you get the idea. This is the input that we need to modify. Right. So we have our point, and we need to get that data x, y, z, and we need to calculate the distance between that point and sorry about that, and that point. All of these points right here that we see underneath. So how do we do that? There's a node called distance2. Distance and 2. Here we go. That's the only one. Obtain the distance from this geometry to another. So let's put it right here. And it takes two types of geometry, any kind of geometry that you want. So we want to calculate the distance between this one point and this other set of points. So let's move that right here, make it a little cleaner. This point, that point, and let's put a watch node so we can see what is going on. Watch. By the way, the watch node doesn't do anything except display the contents of the output. So as you can see, okay, so that first set of points right here on the left-hand side, all of the distances are all laid right here. Second one, third one, third one. Anyway, that's perfect. Okay, so but let's see what happens if I feed that data, those distances, into radius. Let's see what happens. All right, so as you can see, there's a little bit of a problem. It seems that the distances sent to the radius are just way, way, way too big. So we're not getting that nice harmonious radius. So how do we do that? Basically, we need to find a way to reduce these values right here, because these are just too high. Okay. There are fancy ways we can do this, but for now, we're just going to stick to a basic divide node. So because it's just simpler to explain, and for now, we're just learning the basics. Right. So you can divide. So if you type slash, the mathematical symbol for divide, you can divide x by y. So we want to divide these values by another arbitrary value. So let's just say we want to divide by, let's see what 10 does. 10, fit that into here. And now we want to reconnect this output and replace it with the radius of that previous node. And if I click, all right, so we're getting there. We're getting there. There's this slightly nicer thing. So let's slightly change another value. I can type 20, or I can just type times 2. And here we go. That's nicer. We're getting there. And now we need to do another thing, is to modulate the height of these cylinders. So how do we do that? The height of a cylinder is defined by this value. Okay, so that's where if you just understood how this guy worked, we need to do the same with this guy. Right. So let's use copy and paste. Copy, paste. I've got another thing. So I'm using the same distance here, and I'm going to delete this, and I'm going to feed that into thickness, and it's going to control the height of the thing. Oh, so you saw a little bit of a difference, but it seems that it's actually doing the opposite of what I wanted to do. So I don't want to divide. Let's say I want to just use that data straight again. Let's see what that does. Okay, it's a little bit dramatic. So I'm going to divide it by, let's say, 2. So I'm going to use the divide node. Use that, and then put 2 as my divide number, and feed that into thickness. All right, we're getting pretty close to what we want. Yeah, it's actually pretty good. And now the beauty of Dynamo is that you don't have to. The computer does everything for you. So what I mean by that is our attractor point, which is right here. And as I explained in a previous video, you can manipulate these using the slider, as I'm doing right now. Let me just move that into position. So if I just use that slider, you can see that it's recalculating all of the cylinders and all the radiuses and all the heights automatically. And that's the beauty of computational design. Let me just go here and enable, click on this guy, switch to the 3D view, and have a basically more visual way of interacting with the script. And I can just go here and everything computes. So yeah, that's basically it. I hope you enjoyed the video and it was useful. As I said, you can always comment, ask me questions. I'll read all the comments. And yeah, so yeah, I hope you enjoyed the video. As I said, it's the core attractor point right here. And if you open that file, you'll have a kind of basic rundown, basically the contents of that video is in a slightly different form, but as you can see, the output is literally the same. Okay, see you in another video. Bye-bye.